We're continuing in hardware. This should be the last section in 16-2, and we're looking at the I/O controller. And on our block diagram, the I/O controller is right down here. Okay, the I/O controller receives its direction from the system controller, then manages the detail of I/O control itself. And I/O is for input-output. It manages printers, floppy drives, hard drives, keyboards, serial ports, Ethernet, and USB. The serial port, one of the prime things it manages, is slow. It supports modems, keyboards, mice, etc. And I've noted here that it is fading on many newer systems. Sometimes you can have the option not to have a serial port just because newer, better serial interfaces have been developed. And the same with the parallel port. The parallel port, in fact, let's see if I think I have a picture here. This is a picture of a serial port here, and this is a parallel port. And the parallel ports are used for printers, and again I mentioned that they are fading. Many printers that you buy today will not even have the parallel port. Instead, they'll have the little port looks kind of like this, which is the USB port. And that brings us to USB. That is for a universal serial bus. It is a serial port of choice, supporting virtually every device that can plug into a computer, from keyboards to cameras to thumb drives, etc. And it has a bandwidth of 480 megabits per second. And notice it is bits, it is not bytes. The parallel port, remember we talked about parallel, that parallel you'd have the 8 lines, and parallel historically has been a faster interface because you can move 8 bits simultaneously. Serial, when you have a serial bit is like when you have a connected to your modem on the phone and you're moving your data, but you're moving it over one wire at a time. But in recent years, great advances have been made in serial buses, which brought about the USB bus, and the USB bus is very fast. And the USB bus has some valuable characteristics that aren't supported by either of these two. One is that it can support up to 127 devices. And so whereas a serial and parallel, this can only handle one device, and parallel port only one device. The USB you can have over, up to 127. And it also introduced something called hot swappability, which means that with USB you can just plug a device in without having to restart your machine. In the era of serial and parallel ports, if you plugged a device into one of those ports, you would have to restart your machine, which in the older days that just seemed to be the way that you had to do it. But with newer machines, it's just kind of an expected, characteristic that devices will be hot swappable, and that is one of the characteristics of USB. Most machines don't have 127 USB ports in them. Usually they have, 2, maybe 4, sometimes 6. So that brings about the use of hubs, and there are little hubs that you can plug into a USB port, and you can expand your USB capability. I have a couple of these at home. One of them has, let's see, I think it's laid out kind of like this, and there are actually 8 USB ports, and this little hub plugs into one of the ports on my PC, and then I've got 8, and it just seems like I'm using all 8 of them now because just so many things will interface with USB. And so let's see, also another I/O controller is Ethernet. Ethernet is used to connect to networks. It competes with Token Ring and Fiber Distributed Data Interface. I'm just mentioning these because this is not the only way to connect to a network. There are other means. However, worldwide, Ethernet, is like 99.9% of those, and there are these other interfaces, but I'm just mentioning because they technically are different interfaces than Ethernet. And Ethernet is a standard, by the way. If you ever get asked the question, what is Ethernet? Well, it is a standard defined by IEEE 802.3. Okay, then there are infrared. This typically comes under I/O controller, or IR. Data is transferred as short flashes of infrared light, and this is going to be a line-of-sight device. Typically these are used for like PDAs and whatnot for downloading information. And then Bluetooth and PCMCIA, these are a couple of other interfaces that typically come under I/O, though they're not mentioned in your text. Power supplies provide the required level of DC voltage for the computer components to operate from. This usually takes 120 volts AC and converts to 3, 5 volts, and 12 volts. Actually, earlier in this course we spent a lot of time talking about transformers and rectifiers, and that's what you have inside of a power supply. They take the 120 AC and convert it, and then this little switch right here, you can't see what it actually is, but this is going to be a switch for 120/220, and this would be for if you're using this computer either in the US or Europe. Europe's on a higher level voltage, so you would switch that to make that conversion. In Japan, kind of interestingly, they use 100 volts, and usually if it's set for 120, it'll be fine. It's not quite enough voltage, but computers don't seem to be concerned about that. And the DC that's produced by the power supply is typically 3, 5 volts, and negative and positive 12. These are some of the connections that you see on a common PC. Your text doesn't go into them, I'm just mentioning that they are there. Okay, last item that we're going to mention is the real-time clock, often referred to as the RTC chip. And what it does is it starts out with a crystal oscillator, much like the timing chip that we had referred to earlier, but the crystal oscillates at a much lower frequency. In this case, it's 32.768 kilohertz. And again, this is a very stable frequency for crystal oscillation. This particular frequency is fed into a 15-bit counter. Now, something of note, the counter can divide this frequency by 2 to the 15th, or this is equal to 32.678. So if you take 2 and raise it to the power of 15, you actually get this number. And recall that with counters, we can do the functions of dividing. And so in this case, if we divided by the most significant bit, we would effectively be dividing by the same frequency that it's coming in at. So if this frequency is coming in at 32,768 hertz per second, and we divide it by 32,768, then we're going to get a very stable pulse every 1 second. Okay? And so from this 1 second, we can generate minutes, hours, days, months, years, etc. But we have a very stable foundation for generating 1 second. The same timing system is actually used in quartz watches. So in a PC, typically you'll have the 2 crystals on your system board. One will be the crystal that sets up the timing for the various buses, and then the second crystal is this one right here, which is the real-time clock, which gives you your clock in your PC. Okay, this has been this particular section 6.2 has been a quick introduction to the whole subject of computer hardware. We looked briefly at power supplies in this section, the I/O controller, and we, again, this has been a really quick introduction. Your text doesn't give it a lot of detail simply because it is not its emphasis in this particular textbook. If this is a subject of interest for you, you might be interested in taking one of two courses. The EET 131 course introduces the whole world of IT. We spend a whole quarter and we look at nothing but operating systems and computer hardware. Also, there is another course, EET 251, and that particular course looks specifically at a microprocessor for an entire quarter. Okay, this concludes 16.2.